Right now, 11,000 meters beneath the Pacific Ocean, something is moving through absolute darkness. It has never seen sunlight. It never will. The pressure down there would crush a human body in milliseconds, like having 50 jumbo jets stacked on top of you. When two men first descended in 1960, their window cracked at 9 kilometers down. They kept going. What they found at the bottom changed everything. Single-celled organisms the size of footballs. Fish with transparent teeth. 3-meter-tall worms with no mouths, feeding on poison. An entire world that shouldn't exist. We've explored less than 5% of it. We know more about Mars than this place. If you dropped Mount Everest into the deepest point, it would disappear completely with 2 kilometers of water still above it. Only 27 people have ever been to the bottom. 12 have walked on the moon. Nearly 7,000 have climbed Everest. This is Earth's last frontier, the deep ocean. And what's down there is about to change everything we thought we knew about life itself. Our journey begins 150 years ago, when the British ship HMS Challenger was nearing the end of a 4-year mission, the first ever mapping of the ocean floors. Alone in the empty ocean, 2,000 kilometers east of the Philippines, they were taking another routine sounding. A back-breaking job in all weathers, from blistering tropical heat to frozen polar waters. Lowering a lead weight until it touched the ocean floor, then pulling up meter after meter of cold and heavy wet rope. On this day, however, the lead weight did not touch the bottom at 3 kilometers down, nor at 4 or even 5. It kept lowering into the deep. More rope was added, and still it went down. We can only guess how they must have felt as they tied on yet more rope, and that lead weight kept sinking into the depths, right underneath the thin wooden hull of their ship. Sailing the high seas in those times was a treacherous ordeal. Legends told of enormous creatures that rose from the depths, gripping entire ships in their writhing tentacles and pulling them under. This sounds far-fetched to us today, but in those days, such fears were very real. Eventually, the weight hit the bottom, more than 8 kilometers down. What they had found is now known as the Mariana Trench. If they had been just a little further to the west, they would have found the deepest hole in the surface of our planet, the Challenger Deep. 11 kilometers down, the Mariana Trench is vast. A 2,500 kilometer long curved valley on the ocean floor, almost 70 kilometers wide. The Challenger Deep alone, which is only a tiny part of the whole trench, could swallow up 5 Grand Canyons. Finding anything alive there was once believed to be impossible. Conditions are so extreme that even the cells that make up all living things would be destroyed. Bones and shells would simply dissolve, the processes essential to life would come to a standstill. That was until 1960. Amazingly, 2 people managed this crazy descent in 1960. Don Walsh of the US Navy and Jacques Picard, a Swiss oceanographer, made the perilous dive in the Trieste, a tiny bathyscaphe, an incredibly strong pressure vessel resembling a spherical bomb slung beneath a buoyancy tank. At a depth of around 9 kilometers, there was an almighty bang, but that didn't deter our intrepid explorers. They had a quick look around, couldn't see anything amiss, so they continued the dive. What they didn't notice was that one of the thick outer plexiglass window blocks had cracked, one of the key components that prevented their tiny capsule from imploding. It took them nearly 5 hours to reach the bottom. Their view when they got there was limited to 2 tiny viewing ports, just 50 millimeters in diameter. Their arrival had stirred up the sediment on the seafloor, so for a while they could see nothing at all. But then Picard saw something that would shock the scientific community. Life, pale shrimp, and what they described as a dark brown diatomaceous ooze that covered the seafloor. Picard described this moment with excitement. Here, in an instant, was the answer that biologists had asked for decades. Could life exist in the greatest depths of the ocean? They stayed for a mere 20 minutes before having to make the ascent, which took more than 3 hours. What they achieved was so dangerous that nobody else would make the same descent for another half a century. During that time, nearly 7,000 people climbed to the top of Mount Everest, and 12 people went to the moon. To understand what lives in these depths, we must first understand the journey down. Above the surface, there is nothing to see but empty, featureless ocean. There is no land for more than 300 kilometers in any direction. Descending into the water, the first thing you notice is quiet and calm. We are in the epipelagic zone, also known as the euphotic zone. Here there is enough light to power photosynthesis. The phytoplankton here produce half the oxygen that we breathe. This is where the ocean food chain starts. At 200 meters, we enter the twilight zone, the mesopelagic. There is light here, but not enough to power photosynthesis. The water is much colder, and as the light fades, we see the first flashes of bioluminescence. The biomass of fish in the twilight zone is believed to be as much as the rest of the ocean combined. The most abundant vertebrate on the planet lives here. The bristlemouth, possibly quadrillions of them. At 1 kilometer down, we enter the bathypelagic zone, the midnight zone. This is by far the largest habitat on Earth. Covering more than half the planet's surface. The temperature is a steady 4 degrees Celsius. We are approaching the limit that nuclear submarines can dive to. Strange-looking creatures begin to appear. The owlfish uses enormous eyes to hunt. Barrel eyes are small fish with strange upward-pointing eyes, able to see in the pitch dark as far down as 2,500 meters. The anglerfish dangles a small glowing lure. The giant squid has the largest eyes of any animal on Earth, measuring 13 meters long, but there is no reason to assume they don't get bigger. The pelican eel has massive jaws and an extending stomach, capable of swallowing prey larger than itself. The chimera, also known as the ghost shark, has dead-looking eyes, fins like wings, and an abnormally large head. We have now passed beyond the midnight zone and entered the hadal zone, named after Hades, the Greek god of the underworld. As well as being dark and under immense pressure, the temperature here is always close to freezing. Even the shallow parts of the Mariana Trench are 8 kilometers deep. The seafloor here is covered in fine silt. There are sprawling mats of microbial ooze on rock formations, microorganisms that use dissolved hydrogen sulfide to power chemosynthesis, making use of energy from chemical reactions instead of the sun. The main scavengers at this depth are giant amphipods, growing to more than 30 centimeters. In 1998, the Japanese submersible Kaiko discovered Hirundellea gigas, a gigantic amphipod species. This discovery posed a mystery. The extreme pressures should cause the calcium carbonate that makes up their shells to dissolve, yet here they were. They protect their shells using aluminium armor, extracting aluminium ions from the seafloor mud. Here we find the Mariana snailfish, discovered in 2014 and given the scientific name Pseudolaparis swirae to commemorate Sub-Lieutenant Herbert Swire from the HMS Challenger. It's the deepest known fish on Earth, thriving at depths of 8,000 meters. But perhaps the most bizarre are the xenophyophores, single-celled organisms that grow to 20 centimeters or more, almost the size of a football. That is crazy for a single cell. Impossible, yet here they are, made possible by an environment that would destroy cells found at the surface. James Cameron, when he followed in the Trieste's footsteps aboard the Deep-Sea Challenger in 2012, saw these sprawling microbial mats, bizarre-looking filamentous clumps of microorganisms living off chemicals from altered rocks 10,912 meters down in a sunless world. Translucent sea pigs, a type of sea cucumber with long antennae-like projections that act as legs, scavenge the seafloor. They are attracted to carcasses that fall into these depths and will appear in large numbers to feed on those rare feasts. At the far depths of the ocean lies the abyssal plain, a vast, silent expanse of flat seabed that stretches across more than half of Earth's surface, unfolding in depths between 3,000 and 6,000 meters beneath the waves. It is among the flattest, most uniform landscapes on our planet, with long slopes so subtle they vary only a meter or two over kilometers. Sediment falls slowly through thousands of meters of water. The entire seafloor gathered from a fine drift of dead bits and pieces, marine snow. In remote basins, clay can settle at about 1 millimeter per 1,000 years. In the oldest basins, more than 1.5 kilometers of silt lies pressed into the sea floor, each layer a page in the ocean's book of time. Sea cucumbers, soft-bodied and slow-moving, glide across the mud like living conveyors, swallowing sediment and sifting it for nourishment. In some regions, they make up the vast majority of visible life on the abyssal plain. Among them prowl the giant isopods, cousins of the woodlouse, but here grown to nearly 1/2 meter long. Sometimes the plain receives more than drifting dust. When a tree or wooden ship sinks, it becomes a wood fall. Colonies of wood-boring clams and microbes make quick work of its fibers. What makes this remarkable is that there are organisms here that rely almost entirely on wood that can only grow thousands of meters above, on land. These hungers are able to vanish an entire ship in under 100 years. Greater still are the whale falls. When a whale dies, its body drifts downwards until it strikes the seabed. First come the scavengers, sharks, isopods, hagfish tearing the flesh. Then, sulfur-loving microbes colonize the bones, feeding yet another succession of worms, mollusks, and crustaceans. An entire ecosystem rising from a single death and lasting for decades, even centuries. One whale can support life here for years. In famine, many of the animals here can endure for years without a meal. In feast, they gorge until they can scarcely move. From the dark waters drifts the bigfin squid, Magna pinna. Rarely seen, with fewer than a couple of dozen confirmed encounters worldwide. 8 arms and 2 tentacles held at right angles beneath the body, bent like elbows, with filaments dropping like lines into the current. Some individuals measure over 6 meters in total length. Recently, a juvenile was documented in the Philippine Trench at 6,212 meters, the deepest squid observation on record. Where the rock beneath runs exposed, we come to the very seams of the earth, where the crust is being pulled apart. Here, seawater seeps into cracks, is superheated to more than 400 degrees Celsius before rushing back into the ocean. The erupting water carries dissolved minerals, building tall chimneys of stone and metal. Black smokers emit dark, billowing clouds rich in sulfides of iron, copper, and zinc. A living fuzz coats the rock, vast colonies of chemosynthetic microbes. Unlike almost all life on Earth, they have no need of sunlight. They draw energy from hydrogen sulfide, methane, iron, and transform them into sugars through chemosynthesis. The giant tube worms, Riftia pachyptila, root themselves in the vents, their bodies sheathed in long white tubes that grow to 3 meters. These worms stand so tall as to dwarf any human being. They have neither mouth nor gut. Instead, within lies an organ called the trophosome, home to billions of bacteria that feast on sulfides and feed their host. The Pompeii worm builds tubes along black smokers, where water temperature can soar above 80 degrees Celsius. Along its back grows a fleece of bacteria that insulate the worm from extreme heat, detoxify chemicals, and provide nourishment. Deep sea skates use the outskirts of vents to incubate their eggs among warm rocks. At Dorado Outcrop off Costa Rica, Hundreds of deep-sea octopuses gather. Females settle in crevices warmed by hydrothermal seepage, curling around their eggs in patient vigil for years. The eggs of some octopus gardens take up to 4 years to hatch, the longest incubation time in the entire animal kingdom. Closing. The last frontier. At the time of making this, only 400 species have been identified in the hadal zone. That's everything found in all the deepest waters on the entire planet. Compare that to the thousands in a typical freshwater lake. Why do we still know so little about an area that covers more than half of our own planet? The vast expanse of our deep ocean floors is the last unexplored frontier on our planet, waiting to be discovered. The ocean does not begin at the shore. It does not end at the horizon. It begins wherever salt is carried and wherever tide is felt. The ocean is not, at its heart, an expanse. It is an interior, a hollow of the world that drops away beneath us. It is a home to life that has adapted to conditions we still don't fully understand. Life that makes sanctuaries from chemical rain, that survives crushing pressure that would destroy most living cells, that creates light in eternal darkness. This hidden world, Earth's largest habitat, remains largely unknown. The deep sea is one of Earth's last wild and untouched places. Once it's disturbed, there's no going back. What secrets remain hidden in the darkest depths of our oceans? What will we discover? And perhaps more importantly, will we protect it before it's too late? For in the end, the ocean is beautiful, and it is ours to explore or to lose.